In this video, we'll show you some techniques that let you save power without sacrificing functionality. This time we are working with an 8-bit AVR picoPower microcontroller, the ATmega88PA. Our example application wakes up once every second, performs a single ADC conversion, runs a 1000-cycle processing routine and transmits a string with a UART. We monitor the output on a PC at 19,200 baud. The application is powered from a capacitor to emulate a battery being discharged. The AVR device is clocked by its internal oscillator at 8 MHz. The brownout detector is activated at 2.7 volts to make sure everything runs safely. The transmitter string has an incremental counter so we can monitor our progress. How many transmissions can we get through before the power source dies? First, let's try it with no optimization whatsoever. Okay, with no power optimization at all, our capacitor battery is discharged after only 8 UART transmissions. Let's apply some power saving techniques. Using the power reduction register, we switch off everything we don't use: timers, analog modules, and all serial communication except the one UART. Also, we make all unused I/O pins inputs with pull-ups. Recharge the power source, and here we go. 10 seconds. So we just extended our battery lifetime with about 25%. Knowing that CPU frequency affects the power consumption, let's scale the 8 MHz oscillator down to 2 MHz. This also allows us to lower the brownout threshold to 1.8 volts, allowing even further battery discharge. "40 seconds. Okay. 4 times as long as the previous one. An obvious next step is to put the AVR device in power save mode in between UART transmission and the next ADC conversion. "202 transmissions before losing power. An instant 5 times battery lifetime increase from the previous attempt, and we can really see the benefits of picoPower. Now, the main objective of the application is still to collect a piece of data once every second, process it and send it away. If these are the only application constraints and the receiver will tolerate a high baud rate, let's calibrate and pre-scale the internal oscillator to 1.865 MHz. This frequency allows us to use a 115,200 baud rate, so we spend less time in active mode before going to power save. Another 7.5% increase. Not bad. Have a look at this summary of how we have successfully made the battery lifetime of this simple application 27 times longer. If our data processing routine had been longer, we might also have benefited from dynamic clock scaling. We would then use no pre-scaling during data processing and scale the clock down while waiting for the UART to complete data transmission. As you see, it paid off for us to plan ahead and make that simple diagram of our application, as it helped us identify where to employ the different power-saving techniques. These basic techniques can be used with any AVR microcontroller: Tiny AVR, Mega AVR, X-Mega and UC3, because of their range of smart and flexible features that let you save power with no compromise. So thanks for watching and stay tuned.